In this video we have a few right triangles with some unknown sides labeled by x, and we need to use trig ratios to calculate them. Now to set up all the trig ratios, I'm going to bring in SOHCAHTOA to kind of guide my way. And to be able to use SOHCAHTOA, I need to identify what sides I'm working with. So is it going to be opposite side or adjacent or hypotenuse? So from 67, and that's the angle that we use, we always use our 9 right angle. So that's going to be 67 degrees. The side that's across from it is x. So that's our opposite side. We're going to obviously use that one. And then the longest side here is the hypotenuse. We don't have anything there, so we're not going to use that one. But we do have the leftover side right here, which is the adjacent side. So since we have x and 9 here, for these two sides, we're going to use opposite and adjacent. So opposite and adjacent matches up with tangent. So now I'm going to set up my equation with tangent. That's going to read tangent of 67 degrees equals x over 9. And to solve for my x variable, we need to get rid of the 9 in the denominator. So I need to multiply the top part by 9, and 9 over 9 cancels out, so that's why we do that. And then this left side needs to be multiplied by 9 to keep everything balanced. And now we have 9 times the tangent of 67, and that's going to equal x, and we could just use the calculator to get our x value. That leaves us with x being approximately, because we have to round, 21.2. So that's our side there. In B, we're going to go about it the same way. So we want to figure out what sides are x and 14. So the side that is across from 60 is x, and that's going to be the opposite side. Our longest side then of this right triangle, you can see right there, that's going to be the hypotenuse, which is 14. So we're going to use the opposite side and the hypotenuse. That looks like we need to go with sine. I'm going to set up my equation. That equation reads sine of 60 degrees equals x over 14, and we're going to go about solving it the same way as we did over here. We want to get rid of this 14 on the bottom, so we multiply the top part by 14, and then this left side gets multiplied by 14 as well. So 14 over 14 is 1, so that goes away, and I could rewrite everything. So we have 14 times sine of 60 degrees equaling x, and I can bring in my calculator to get x. That's going to give us about 12.1 for our value for x. Alright, let's do part C now. So we're given 55 degrees. Again, we're going to use that angle, and we want to identify our side. So the side that is across from 55 is 9.1. That's the opposite side. And then the longest side, we're given that value is in our unknown, which is x, but we know that it is our hypotenuse because it's visually the longest side. So again, we're going to use sine because we have the opposite and the hypotenuse. So our equation is going to read sine of 55 degrees equals 9.1 over x, because 9.1 was the opposite side, and then we're dividing it by our hypotenuse. So this one is a little bit different because we have our x now in our denominator. Before, our x was in our numerator, but now it's in our denominator. So we want to get it out of the denominator. So to cancel out that x, we needed x on top. So I multiply the top part by x. And then that means I have to balance my equation. So this left side gets multiplied by an x as well. So now I'm going to rewrite it. And that gives me x times sine of 55 degrees equals 9.1, because our x over x went away. Okay, but now we need to get x by itself. And to undo the multiplication here, we want to divide out that sine of 55 degrees. So I do it to the left side, I also have to do it to the right side. So now sine of 55 divided by sine of 55 is just 1, it goes away. And I'm going to rewrite everything else. I'm left with x equaling 9.1 divided by sine of 55. And I'm going to use my calculator to get that answer. And that will be about 11.1, which will be my value for x. There are a couple ways that you could go about solving this part C, but this is just the one that I like to use just because it's very consistent with the way I solve for A and B. But multiple ways would work.